Okay, the next example is between calcium and this chromate anion. So as you can see, calcium and this anion has identical numbers. And as you remember, when they're identical numbers, we do not write them down. We just write as it is. So you just lose your charges and numbers, and you just write calcium and you add up, no parentheses. If you write parentheses, it's not going to be like a mistake, but if it makes you feel more comfortable writing the formula, you can still write. The next example is between aluminum that has a charge +3. It's a metal, therefore its cation has a charge +3. And this is something called hydroxide. This is an anion and it has a charge -1. So when aluminum reacts with hydroxide, OH, it loses its 3 electrons, it donates it to OH, and when you write aluminum's first, and then you write parentheses next to OH, and on the bottom of those parentheses, you write the number that belongs to aluminum. So you write 3 over here, okay? Next one. Write the chemical formula for the ionic compound formed by each pair of ions. So here you go. This is a little bit more complicated. This is called ammonium cation, and this is nitrate. Both of them have identical numbers, +1 and -1. Even though the charges are different, the numbers are the same, +1 and -1. Therefore, you don't need a parenthesis here. You just combine them together and lose the charges. So NH4, NO3. This is your compound. Next one is a little bit different because over here we'll be adding 2 to your hydrogen. Hydrogen over here is a cation, has a positive charge, and this polyatomic ion has a -2 charge. So this 2 will go to hydrogen. You do not need parentheses for the first element. So you don't need parentheses for the first one because it's just one ion. It's not a polyatomic that consists of several ones. Remember how we did before? Same thing we were doing over here. You just write it over here, no parentheses. But when you have polyatomic ions, you have to write those parentheses to specify that this whole thing, we need the 3 of it, not just 6 or 9 oxygens. We need 3 of the whole thing. Next example is between copper, and this polyatomic ion is called carbonate. So copper has a charge +1, carbonate has a charge -2. Therefore, here's my mistake. You write 2 for copper. Copper has 2, carbonate remains the same. So this is an example between sodium, and this particular one is called bicarbonate. Bicarbonate has a charge -1, sodium has a charge of +1, Na plus, HCO3 minus. Both of them have identical numbers for their charges. Therefore, the formula is sodium bicarbonate, NaHCO3. Okay. For each pair of, question number 9. For each pair of elements, determine the charge for their ions and write the proper formula for the resulting ionic compound between them. Barium and sulfur. So, barium is in the second column, right? So its ion should have a charge +2. The same table that I was showing you before, second column. So the charge is +2. The sulfur is in the 16th column, and it should have a charge -2. So when these two react, barium and sulfur, they create compound called barium sulfide. So it has charge +2. This one has a charge -2. Two same numbers, just different charges. You drop them and you get barium sulfide. Okay? Like this. Cesium and iodine. Cesium has a charge +1 and iodine is located in 17th column and it will have a charge -1. So when those two react, cesium and iodine, you see +1 and over here is -1. The final formula is going to be like this. So CSI. This is the same type of question, but now it's asking you about potassium and sulfur. Potassium is in the first column, so it will have a charge +1. Sulfur is in 16th column, therefore it will have a charge -2. So we do the crisscross method. Sulfur has 2, so potassium will have it. So the final answer is K2S. So this 2 went on the bottom of potassium, and this one went on the bottom of sulfur. Which compound would you predict to be ionic? Remember how I told you that ionic compounds consist of a positively charged ion and negatively charged ion? So all metals are positively charged. So if you see a metal, remember where metals are, first, second column, and some in the middle of the periodic table. So barium is in the second column, so it's definitely positively charged. It's metal, therefore it's ionic compound. And over here I explain to you why. This type of compound is non-ionic because there's no metal, so therefore there are no positively charged ions over here. So that's why it's non-ionic. Same type of example. A lot of non-metals, all of them are non-metals. Therefore, it's non-ionic. This one is a tricky one. Really wanted to trick you. Ammonium ion is usually positively charged and sometimes it acts like metal. Therefore, remember this one. This will haunt you probably for a while. This is shouldn't have done that. This is an ionic compound because it has a positively charged part and a negatively charged part. Okay. This is definitely non-ionic because it has two nonmetals. Doesn't matter how many of those you have. C8H18. So this is non-ionic. Ammonia or NH3 is non-ionic because it has two nonmetals. It's different from you have seen. This is ammonium ion. This is just neutral ammonia. It has no charge to it. Okay, let's continue. Page 179. Write the formula for each ion. Again, you need to be familiar where each element is located in the periodic table. And the same table that I provided to you, you will need to find the charge for it. It's very easy if you can locate it right away. Some of these things you need to memorize. I'm not sure how much will Dr. Charna go over the polyatomic ions. You might need to memorize some of them as well. So this is a fluoride ion. You look for fluorine and you know that it's in 17th column. So it has a charge, -1. So here's your fluoride ion. The carbonate ion, something that you should memorize. CO3 with a charge -2. This is not something you can easily find in the periodic table. This is something that you need to memorize. The stannous ion. So this is tin, also called the stannous or tin ion. So there is a common name and not so common name. The tin has a charge +2. And the potassium ion, easy. Potassium is located in column number 1, therefore it has a charge +1. Stannous ion can have different type of charges. This is something, there is a table in your book that you actually need to kind of understand in order to solve these problems, because the names can be a little bit tricky for transition metals. Tin is a transition metal and it can have different charges, therefore the names are different for the tins that have different charges. Okay, page 180. Name each ionic compound using both stock and common system if necessary. I really do love the stock name. I'm not really a fan of common systems. The stock name is actually the name that most of the chemists use. So the first one, you have 1 zinc and 2 bromides. It doesn't matter if you have 2 or 3 or 4. If it's an ionic compound, you do not care how many of these you have. You just write the name of the metal and non-metal. So over here, zinc, bromine changes to bromide. Bromine changes to ide. Next one, you have iron and nitrate. Iron is a transition metal. You have to identify what is the charge of this iron. In order to do so, you need to know the charge of your nitrate. So nitrate you need to memorize. It's -1 always. And iron can be +2 or +3. You have to write in parentheses the Roman number of the iron charge over here. So another trick, you can see that this is 3, right? So iron can be +2 or +3, so it definitely has a charge +3. Remember the crisscross system? This iron has only 1, so this one is probably -1. So iron, the stock name for the element, the charge is +3, and the name of the polyatomic ion is called nitrate. Common system is ferric nitrate. So iron that has a charge +3 also can be ferric. Iron that has a charge +2 is called ferrous. Next one, this is easy. Aluminum oxide. Anything with oxygen, you change to ide. Not oxygenide, but oxide, like bromide, remember? Next one. Name each ion. This is not too bad because you have to write, for metals, it's usually the name of the element when you add ion. So radium, ion. For non-metals, it's not phosphorus ion, it's phosphide ion. You change the ending of it. For this particular is hydrogen. You know what hydrogen is. And this part is called phosphate ion. Something you need to memorize. Sorry, can help you here. You remember that tin can be 2 or 4. It's a transition metal. Therefore, you need to write the charge in parentheses in Roman numbers. So 10 parentheses, the charge is 4. You write 4 in Roman numbers, ion.